Hello, my name is Michelle, and I wanted to do the Ethernet project that comes with Vitis for the lightweight iPerf UDP server. However, I noticed that there were no videos out there that did this, which was quite surprising. I mean, especially now that I've done it and I realize how simple it is, and maybe that's why nobody recorded the video. But anyways, so here it is for you guys. Hopefully, I help you figure out some of the things that I needed to figure out in order to get this to work. Basically, I'm using Vivado 2020.1. I created a basic project, which you can see here. I'm using a Zybo Z7-20 FPGA. So it's just a basic project I created. At this point, I'm going to go ahead and create a block diagram. And I'm going to call this my I was leaving it as design one. What the heck? Doesn't hurt. And I'll wait for it to create. And then we're going to basically instantiate a Zinc processor. I mean, this is a very simple project where we'll run our automatic connections. All right, so all we really need in this processor is our Ethernet and our UART so that we can send out the commands to our COM port. So we're going to go in here and we're going to get rid of some stuff and then make some changes. Let me expand this so you can see it better. Okay, so basically I don't need the reset, right? So we'll get rid of the reset. And I don't need my AXI master. So we'll get rid of that. And basically on the peripherals, like I said, I want my Ethernet 0. I'll leave everything alone, though I don't really need it. And my UART 1 I need. On my Ethernet 0, just make sure that my MDIO is selected. We go to the MIO. And basically, in here, I want to make sure on my Ethernet, and we'll expand it down, that I am using the MIO IO, and that it is, I hate that this does this. For each signal, I want to make sure that that is a 1.8 voltage, which they are. And here's an important aspect. They default normally to slow, or at least it does for me. And so you want to change these all to fast. And that's just the main change I have to make here. I'm trying to see what this is. There. Okay. So basically, we're making sure that the MIO is selected for the Ethernet, and then that they're 1.8 volts and it's fast. And that's 1.8 volt because that's what it calls for in the I do believe for the PHY, it's probably what requires it. I know that in the tutorials for the Zybo, it does say to use that. Basically, for the clock, we don't really need the clock, so we can disable the clock. Okay, there you go. And then the only important thing is just, I have a board package here, so it automatically selects my DDR, but if you don't, you want to make sure you have the right DDR settings set up. Otherwise, your program won't work. So that's basically about it. You hit OK. And as you can see, for some reason, DDR puts it in negative. Don't worry about that. And so here you go. You basically see that it's very basic. You got your DDR. You got your basically your UART. And then you have your Ethernet's enabled. So at this point in time, you can validate it. All right. Then you could go into your source. You could tell it to generate your output sources, and then once that's ready, I'm not gonna rebuild it. I already have it built. Basically, you generate your wrapper for it. Goes out and generates the wrapper, and then at that point in time, Once the wrapper is generated and and you could come down and say, I want to generate my bit stream. Basically that pops up and says, oh, do you want to generate it? Yeah, and you select, how many jobs you want and everything like that. When it's done, the bit stream is done. At this point, you could close this out. It doesn't matter. Um, it's irrelevant. I'm going to close that out. And then you can go to File and export your hardware. Yeah, I didn't create anything, so there's nothing to export. But you would export your hardware. Surely you know how to do that. Um, and then you would run your SDK. In this case, I'm going to go ahead and have my SDK up and running now. All right. So once you pull up your Vitis, you want to create your platform, which I already have done as well. When you create your platform, one thing you do need to change though is you want to go into for your because we're not using Linux and we're not using FreeRTOS. We're just going to use the standalone. So basically, you want to make sure in your board support package that you modify the BSP settings and make sure you select your lwIP libraries. That way, when it'll run because you need the required. All right. So once you've done that, you basically could say okay, and then you go out and you build your platform, right? Which will take a couple minutes to do when you're running it. And so once it's built, and you have to build it first because if you don't build it, then when you go to create the new applications, it won't see that the libraries are there and it'll complain. So you want to make sure you build the platform first. After that, then you go out and you create a new application. And you go out and you say, all right, I want to use my platform. Um, in this case, we're gonna use a UDP server. So I'm just gonna call this server because I already have it created up there, but I'm just going through it for you. So we're gonna use our server. Go next. Again, using the standalone. Next. So it goes out there and says, I don't know. So now here it's saying, well, what template would you like us to use? Well, like I said, we're going to use the UDP Perf Server. All right, and then we hit finish. All right, once you do that, it goes out and creates your application. In this case, I'm going to use right here. It is for me. And in here, basically, you have your main, and in there, you have your your IP addresses are listed, and I'll go ahead and pull this up. Your IP addresses are listed. This was the default ones here. These more worked with my server that I'm using. And so I went ahead and changed the IPs to work so that I could, interface with my PC. And then the default MAC address that they give you, which is a Xilinx one, I actually I just changed it so that I could have two devices for a future project that I'm going to record. Oh, well, needless to say, that's the only change I made to this right now, just so that I could do this illustration for this project. All right, so once you build that, and you're ready to go, you have your FPGA turned on, and you're ready to program it. So then you go ahead and say, okay, let's run this. And I'm going to go ahead and say run as on hardware. At that point in time, I have my COM port already ready, so I'm going to bring my COM port over. And so it just programmed my FPGA. And so now you see that it's coming up and it negotiated and it connected to the server, and it's saying that the server is now listening on port 5001. And what you can do at that point in time is you can go to your download iPerf onto your computer. The first time I did this, I downloaded iPerf 3, and it didn't work, and I couldn't figure out why. So then later, after some research, I discovered that iPerf 3 doesn't work with this, so therefore you got to use iPerf 2. And so basically, here's my command prompt. It says enter in this. I'm just going to select what it says to enter. You'll notice that we're using iPerf. The -C says it's a client, and this is the host that you're going to connect to. The dash T is a timing thing. Dash U says you're using UDP, and then dash B is your bandwidth. We're going to put a 0 next to it, so it's unlimited. So I'm going to copy that. I'm going to bring it over here. I'm going to paste it in, add my 0, and I'm going to say, okay, let's go say, give me whatever you're trying to send, server. When I click it, it's basically connecting and it's doing its handshaking, and well, now we're getting some packets. They're coming in. And as you can see here, it's saying, hey, you're on the, this is the IP you're at, this is the port you're running, and you're now connected to, let me click this, to this IP address and at that port. And so as you can see, um, we're basically transmitting packets. I'm going to hit Control C here, just to stop it from keep saying stop sending me stuff. So as you can see at this point, like I said, it's going back. We were sending this in this case 10 kilobytes per second, and our bandwidth was 13.6 kilobits per second. This is how many bytes we were sending. That's bits per second, and we had sent 7 of them here, and 7 and 6. And it basically, once it sends the first one, it's successful because it sent it and it was received. I don't know the logic yet. I haven't really dug into that, other than to say, okay, we got this thing to work. So I have now an UDP client, a server, and it's receiving by a client. When you go, oops, let me go get my command prompt back up. What I also wanted to show on the command prompt here is that we were this IP, which is my PC, at this port was connected with the server at that port, and then here's what we received. We received, in this case, it was 0 to 5 seconds. It said we received 8.61 kilobytes, and it was basically around 14.1 kilobits per second is what we were receiving. So the other one was transmitting, and this is what we were receiving. Let's go back to my COM port. So this was my transmitting. This is what I received. Um, so there you go. There's pretty much how this works. Um, and that's basically how the lightweight iPerf UDP server is run. And that's it. So I hope you enjoyed the video. Hope this helped you a little bit. The iPerf part was the only thing that I really needed to figure out that I didn't know before. So, but at least now there's a demo out there that says, hey, this is how it works. So enjoy. Thanks. Appreciate it. Bye.